Let's continue with the arc length of a parametric curve. In this section, we evaluate the length of a parametric curve. Let's consider the curve described by x equals f of t, y equals g of t, where t is between a and b. Now, where f prime and g prime are continuous and the curve is traversed once for t greater than or equal to a and less than or equal to b. Then the arc length of the curve between f of a, g of a and f of b, g of b is, and this is the formula, L representing the arc length equals to the integral from a to b, those are the limits of the parameter, and then square root of f prime of t squared plus g prime of t squared dt. F prime of t is found from here, from the parametric equations. So we just take the derivative of x, dx dt, and that will be f prime of t. And also we take the derivative of y, dy dt, and that will be g prime of t. We square them and then we put them in the formula. And then we find the arc length. Let's continue now with this example. In this example, we want to find the arc length of the following curve. And this curve is x equals cosine cube of t, y equals sine cube of t, where t is greater than or equal to 0 and t is less than or equal to 2 pi. So this curve here, as we remember, represents the asteroid. So the graph of the asteroid, as we have seen, is something like this. And this asteroid has 4 parts which are symmetric. This portion of the asteroid, this portion, they are symmetric. So what we will do is we will find the arc length of this portion only. That portion goes from t equals 0 to t equals pi over 2. And then we find that arc length L, the total arc length will be 4L. Alright, so that will be our strategy. We are going to find 4L, where L is just that portion. So we start. So we say, the first step, we say the arc length will be equals to 4L. Now to calculate L will be equals to the integral from a to b, I am using the formula, of square root of f prime of t squared plus g prime of t squared, which we can also write it as dx dt squared plus dy dt squared. And then we integrate with respect to t. Alright, now let's substitute values. L will be equals to the integral from a to b, but a is 0 and b is pi over 2. And then we write the root of dx dt. So we write d dt and x is cosine cube of t, And then we square that derivative. That's what the formula says. And then plus d dt of sine cube of t, and then we square this derivative. And then we integrate with respect to t. Alright, in the next step, we are going to evaluate those derivatives and we are going to use the chain rule, as you will see now. So we say the derivative of cosine cube of t. First, it will be 3 cosine square of t by using the power rule. And now by using the chain rule, we need to multiply times the derivative of cosine, which is negative sine of t. Now we square all these derivatives. That's what the formula says, squared. Plus, now we take the derivative of sine cube of t, which will be 3 sine square of t. And then use the chain rule to get the derivative of sine, and that will be cosine of t. And the formula says to square all this derivative. And then we integrate with respect to t. Now we continue with the algebra. L will be the integral from 0 to pi over 2. And then root of this expression squared will be equals to 9 cosine to power 4 of t. and then negative sine of t when we square it, and that will be positive sine square of t. So the negative sign is cancelled when we square it. And then plus the second term now, this term squared, it will be 9 sine to the power 4 of t times cosine square of t. And then we take the root, and then we integrate with respect to t. Next, what we do is we factor from these two terms. We are going to factor 9 cosine square of t sine square of t. So we are going to have L equals to the integral from 0 to pi over 2 root of, and then we factor 9 cosine square of t sine square of t. And then in parentheses, when we remove from here 9 cosine square of t sine square of t, then we are going to leave cosine square of t, which we write here. Now on this term here, when we remove 9 sine square of t cosine square of t, we leave sine square of t. And then we close the radical, and then we integrate with respect to t. And look, this cosine square of t plus sine square of t, that is equals to 1 by using trigonometric identities. So now, this L will be just the integral from 0 to pi over 2 of this term, 9 cosine square of t sine square of t, and all this will be under the radical sign. So let's write that next. L now will be the integral from 0 to pi over 2, and then root of 9 cosine square of t, this is cosine square of t, and then sine square of t dt. Okay, now we take the root of this perfect square. Now we have to use this formula. We know that if we have x squared root, this is equals to absolute value of x. We have to use this because we are integrating. We cannot avoid this. So we write L will be equals to the integral from 0 to pi over 2, and all this will be absolute value of 3 cosine of t sine of t. And this is where we are. Next, since we are integrating an absolute value function, then we need to use the definition of the absolute value. So we know that absolute value of x is defined as x if x is greater than or equal to 0, and it is negative x if x is less than 0. Now, how about the sign of t in cosine of t, where when t is between 0 and pi over 2? So let's write that in here. We know that t is between 0 and pi over 2. So what is the sign of t? Well, if t is between 0 and pi over 2, then sine of t will be greater than 0 and less than or equal to 1. The same with cosine of t. Cosine of t, when t is between 0 and pi over 2, is greater than or equal to 0 and less than or equal to 1. And then the product, sine of t, cosine of t, will be between 0 and 1 as well. So conclusion is that from here, that cosine of t times sine of t is greater than or equal to 0. And we multiply by 3, it still is greater than or equal to 0, which means that we are going to use this portion of the definition of absolute value, of the function absolute value. And then we are going to write here L equals to the integral from 0 to pi over 2, and now we can just get rid of the absolute value bars, because this expression is greater than or equal to 0. So its absolute value will be equal to 3 cosine of t sine of t. Now we integrate this integral. So now in here we can make a u substitution. We say u equals to sine of t, and then du will be cosine of t dt. So now we write this integral in terms of this new variable u, and at the same time we are going to change the limits of integration. So we start the integral. Now let's change this limit of integration. When t is equal to 0, we substitute here, and sine of 0 will be 0. Then u is 0. So we write that lower limit here. Next, when t is equals to pi over 2, we substitute here again. Sine of pi over 2 is 1. then u will be 1. And we write that as this limit. And now we write all this integrand in terms of the new variable u. This is u, sine of t is u, let's write that u in here. And then 3 cosine of t dt, it'll be 3 du. Because if we multiply here times 3, this will be equal to 3 du. So let's write that 3 here, and then the du here. Now we just integrate this. This integral will be 3, and then u squared over 2. And then the limits of integration will be from 0 to 1. We continue. This will be 3 over 2, and then when u is 1, this will be 1 squared. When u is 0, will be minus 0 squared. So this will be 3 over 2. 3 over 2. All right, now let's find the arc length. So this will be our answer now. The arc length, we say here that it will be 4L. We just found L. So now the arc length will be 4 times the value that we just found. The arc length of the whole asteroid in this problem will be 4L, which is the same as 4 times 3 over 2, and this will be 6. That is the answer. That is the answer of this problem.